Okay, we're going to start our study of physics the way my high school physics and the way back in the dark ages started. And we're going to talk about vectors and scalars. Now, he started out by saying, what is 2 plus 2? And we all said, okay, it's 4. And then he said, is it always? And I'm going to give you an example where, depending on how I ask the question, 2 plus 2 is going to equal 4. But if I ask it in a different way, it won't equal 4. So the student walks 2 miles north and then 2 miles east. And in part A, we're going to say, what is the distance he has walked? Well, the distance, we're just going to take the 2 miles that he walked north and add it to the 2 miles he walked east, and we're going to end up with 4 miles. So if I wanted to know the total distance, I don't have to worry about direction, and I just do 2 plus 2 equals 4. Now, if I ask this, though, what is his displacement? Displacement is the position relative to the starting point. It's not going to be 4. We can draw it in here. There's the starting point. And we'll draw that he went 2 miles north, and then he went 2 miles east. And he's not going to be 4 miles away from his starting point. His displacement we can draw in here. Okay, and I'll label it D for displacement. How am I going to find his position relative to his starting point? Well, since north and east meet at right angles, I can use the Pythagorean theorem. So D squared is 2 squared plus 2 squared. Now, this 2 squared over here, that's going to give me 4. 4 plus 4 is 8, so D squared equals 8. And then D, if I take the square root, is going to be 2.83 miles. Now, I haven't fully defined his displacement. His displacement is his position relative to his starting point. I now know he's 2.83 miles away, but I haven't told what direction he's in. So, I have to define that. Now for this one, it's pretty straightforward. Since he went the same distance north as he went east, we can call this straight northeast. If those aren't the same, he goes a different distance north than he does east, we have to determine the angle. But in this problem, we're not going to have to do that. So, in this example, we're asked to find distance, which is a scalar, which I'm going to define in a second, and displacement, which is a vector. Scalars are quantities which have only magnitude. Magnitude is a fancy word for size. Don't let it scare you. Okay, so the magnitudes of the student as he was walking, he went 2 miles north. The magnitude would be 2 miles. Then he went another 2 miles. Another magnitude of 2 miles. His total was 4 for the distance. And you can just add them if they're scalars. But vectors are quantities that have both magnitude, so they still have a size, and they have a direction. Okay? You can't just add them, you have to take the directions into account. So 2 miles north plus 2 miles east does not make a displacement of 4 miles. I have to try and figure out what it is. In the case we did, we could just use the Pythagorean theorem. Now, I represented those as arrows because arrows can represent both the size and the direction. Okay, and the size of the arrow represents the magnitude. So my 2 arrows were the same length, it was 2 miles and 2 miles. If I had 2 miles and 4 miles, the vector representing the 4 miles would be half as long as the vector representing the 2 miles. Now, top of the next page. Now, when we're doing our addition, if they're not going to meet at right angles, sometimes if we do a scale model, that can help us. Okay, in order to do a scale model, we have to be able to draw our vectors to scale. So we're going to do this example. Okay, from the common origin, we're going to draw the following vectors to scale of 5 meters equals 1 centimeter. So we're going to start out with a vector of 20 meters west. So I got to figure out from the scale. If 5 meters is 1 centimeter, 10 meters is 2, 20 meters is going to be 4 centimeters long. So I'm going to make a note of that here. All right, I have to make it 4 centimeters long. And it's pointing west. Okay, west is going to be to the left. So I'm going to put my origin down here. Okay, so I'm going to start down in here and put my origin. And then I have to use my ruler and measure out 4 centimeters to the west. So I'll put my ruler right here. And then I will just use my arrow and draw like this, 4 centimeters left. And then I might label that saying that this represents a 20 meter long displacement. The next one's 40 meters north. So I know I'm going to have to go up. Now again, my scale is 5 to 1, so 40 is going to be 8 centimeters long. Okay, you'll notice that vector B is twice as long as vector A, 40 meters instead of 20. So on my scale, it's going to be twice as long, 8 instead of 4. I'm going to pause this a second while I rotate the ruler. Then I'm going to take and drag the ruler over to my origin, and it has to be 8 long. So I will put it here. And 8 long is going to take me to here. So I'm going to draw up and draw an arrow. Now that vector then represents my 40 meter displacement. I have no idea where the line just went. Okay, now we have to do the last one. And for the last one, I have to do a little bit more work. I have to do 25 meters. So use my scale. If 5 meters is 1 centimeter, 25 meters is going to be 5 centimeters. But I also have to draw in this 40 degrees north of west. The second word is my reference line. Okay, so I'm going to take my protractor and drag it over to my origin. And I'm going to set it so the origin of the protractor is on the origin of my drawing. And so my reference line is west, and I want to swing 40 degrees north of that. So here's 0, and I move up. There is my 40. So that is 40 degrees north of west. So I'm going to pull my protractor out of the way. And now I have to measure along that line 5 centimeters from the origin. So now I've moved my ruler over so that it's right along my line, my 40 degree line. And now I'm going to draw in my vector, and I have to make it 5 centimeters long. So I'm going to draw it in like so. Now if I want to be particular about this, I'm going to label that this angle down here is 40 degrees and that this represents 25 meters. So that's representing vectors. So at this point, you should be able to define vectors, define scalars, and be able to represent them in a scale model.